Okay, next we're going to solve problems with systems of equations. We're going to solve problems with systems of equations based on example 3.
You know, it's one thing to solve one equation when you have one unknown, but sometimes in life we're faced with two equations and two unknowns. Things get twice as tricky, but twice as fun, because what we first try to do is see if we can eliminate one of the variables, and then if we can eliminate one of the unknowns, we can solve for the one that's remaining, and then once we have that answer, we can plug it back in and solve for the second one. Let's take a look at an example where you can see two equations with two unknowns with only one solution. Let's check it out. So, the Manatee Club wants to buy water skis and coolers. The club will spend $388.50 to buy them at Top Sports and $443.50 to buy them at Outdoor Explorer. That's before taxes. Now, the Top Sports is further away. That's why it's not clear which one they want to buy it. Do they want to spend fewer dollars, $388.50, to buy it? But it's so far away, they got to take an airplane or spaceship to get there, or to spend $443.50 to buy them, and it's right next door. Anyway, it's a conundrum, but those are the facts. And the question is, how many of each item does the club intend to buy? It seems like a riddle that we might not even have enough information to answer. But let's think about it together. Here's what we know. This little table shows what goes on at Top Sports. They sell water skis for $78.75 per pair, and the coolers for $24.50. At Outdoor Explorer, same price for the coolers, but notice that the water skis are a little bit more expensive. They're $92.50. What do we know? We know that whatever number of water skis and coolers they're going to buy, when you buy them at Top Sports, it's going to cost exactly $388.50. We know that if they buy the exact same number of water skis as they did before, and the exact same number of coolers as they did before, out at Outdoor Explorer, it's going to cost them $443.50. So the question is, just knowing that and nothing else, can we figure out how many pairs of water skis they want and how many coolers do they need? Well, the interesting thing is the answer is yes. We actually have enough information. And the way to think about this is to say, you know what? We don't know how many of each they're going to be, so let's just give those unknowns a name. So let's call the number of water skis that they're going to purchase at either store, let's just call that X. You can use any letter you want. I'll just use X. And the number of coolers they're going to buy, Y. So now I can actually say the information in a slightly different way. With the Top Sports, they're going to spend $388.50 buying X water skis at that price and Y coolers at that price. Alternatively, they could spend $443.50 and buy X number of water skis at this price and Y number of coolers at that price. Now, saying it that way, we can now convert those things to equations. So, for the Top Sports, in fact, let's just try the Top Sports. What does that say? What it says is, X times that amount is the total spent on water skis. Y times this amount is the total spent on coolers. And if we add them up, that's got to equal this. And so magically, we have created this equation. That's really cool, right? 78.75 times X plus 24.50y equals 388.5. That's exactly what we have here. And we can do the exact same thing with the Outdoor Explorer. In fact, let me just slide this over so life will look nice. The Outdoor Explorer will have a similar equation. It'll be $92.5x plus 24.5y equals that. So now we have two equations and two unknowns. And the question is, can we actually figure out what x and y have to be? And the answer is yes. So let's now let these guys fade into the background. They've served their purpose. And now let's take a look at these equations. And what I notice is I have two equalities. Here's an equality and here's an equality. And notice something very interesting is going on here. This is an amazing coincidence. Do you see it? The coincidence is that I seem to have these things look the same. And so therefore, if I take these two equations and subtract one from the other, then what I'm going to see is that this term added with, or this term subtracted from this term will give me 0. So that unknown, that extra variable will drop out, leaving me with just one equation with just x's. And so that is the idea. So let's see if we can actually make a go of that. And what I want to do now is just subtract these two. Now, if I have two things that are equal, this thing and this thing, and I subtract them, then the result will still be equal. So I'm going to subtract both sides. When I subtract this side, notice that 24.5y minus 24.5y, that just gives me 0, which was the whole point. So that just goes away. And then I have 78.75x minus 92.5x, which is the same thing as taking 92.5x and subtracting 78.75x and putting a negative sign in front. When we do that, we see negative 13.75x. That's now 0, and that equals 388.5 minus 443.5, which equals negative 55.
Okay, now all he did here was he recognized that these two numbers are the same, just like in the previous example in example 2. If these are the same, that means you can subtract or make one negative to eliminate. So you make the bottom one negative. But you have to remember that if you make this negative, then everything else must become the opposite also. So 95.50 times x becomes, 92.50x becomes a negative 92.50x. The positive 24.5y, it becomes a negative 24.5y. And the 443.50 positive, it becomes a negative 443.50. Now you add going down. Add going down, this becomes a negative 13.75x, the positive 24.5y, and the negative 24.5y, they cancel out. That's why that's gone. So you see nothing there. That's canceled out. That's gone. And it's going here. See? And then you add going down here, and you end up with a negative 55. So now you have a negative 13.75 times x is equal to a negative 55.
Well, now look, we have one equation with one unknown, and so we know exactly what to do. We have to undo the multiplication by negative 13.75, so I divide by negative 13.75 to undo that, so I'm just left with x alone. But if I do it on that side, I've got to do it on this side, so here it is. And now, simplifying this side, I just get x. Couldn't be any easier. Now this side, a negative divided by a negative is a positive, so that's positive. And if you actually take 55 and divide it by 13.75, if you work that out, you actually get the number 4. And so we see that x equals 4. And what does x represent? X represents the number of pairs of water skis they want. So we just figured out what x is. X has to be 4. I'll write that in right here. So 4 water skis. That's awesome. Now, what can I do to figure out what the y value is, the number of coolers? Well, look, I now know what x is, so it's no longer a mystery, it's no longer an unknown. I can just plug in the value 4 for x. We know what that equals. And we can use either of these equations to just get rid of the x stuff and now just have something in terms of y. Let's just consider the top one. So I'm just going to consider this top one. And we'll take all this work that we've just done. I'll just throw it away. We don't need any more. Say goodbye. Goodbye, work. And so now I'm just going to take this equation, and I'm going to let x equal 4. And when I do that, what I see is 78.75 times 4 plus 24.5y equals 388.5. In particular, notice that the only thing we don't know is the y. So now it's a usual good old-fashioned equation we could solve for y. And so if we actually multiply the first part out, we see 315 plus 24.5y equals 388.5. And so to undo the addition of the 315, I'll subtract 315 from this side. I'll subtract 315 from this side. But that means I got to subtract it from this side. You know why. Because otherwise, it won't be fair and balanced. So when I do that, now this just adds to give 0, so I'm just left with 24.5y equals, and on this side, I'm just left with 73.5. And to undo the multiplication by 24.5 on the left, I'll just divide both sides by 24.5. So it'll simplify just down on the left to just y alone. And so I'm left with y equals, and when you actually do this division, you would see 3. And what does 3 represent? It represents y, which represents the number of coolers. And that's why it's blue, because it's cool. It's a cooler. So, if I want to...
Now, the way he came out with 315 here was 78.75 times 4. 78.75 times 4 would give you 315. Then you bring down your 24.5y. Then you bring down your 88.5. Now you're back to solving a two-step equation. Multiplication here, 24.5 times y, and addition here because it says a positive 315. And you remember, you start working with addition or subtraction first. This is a addition or a positive 315, so therefore you subtract 315 from both sides.
Right, the answer as an ordered pair, x comma y, skis comma coolers, the answer would be 4 comma 3. But what that means is that just given the information we had, which was the information from this chart, this table, together with these two pieces of information, we're able to see that no matter where they want to buy from, they're going to be buying 4 pairs of water skis and 3 coolers, no matter where. And the way we saw that was taking the table information and this extra stuff and creating 2 equations in 2 unknowns and actually trying to simplify by getting rid of one of the variables and solving for the other. And then once we have the other, we plug in and solve for the other. Solving simultaneous equations. It sounds like a mathematical tongue twister, but it's actually a lot of fun and really important because lots of information we see in our everyday world actually involve lots and lots and lots of unknowns. And our job is to look at all the information, create lots of equations, and over time, slowly, reduce, reduce, simplify, simplify, and using our algebra skills, we can solve for x, solve for y, solve for z, solve for w, solve for b, solve for... You get the idea. Solve for c. I'll see you soon. Solve for d, solve for...